Good morning, good afternoon, and good evening, everyone. I kind of sound like Walter Cronkite doing that, but thanks so much for your kind attention. Today, I'm going to be talking a bit about taking knowledge graphs to the next level using something that some of you may be familiar with, my classification protocol. So the title of my presentation today is Faceted Graphs, Multidimensional Views Using Natural Language. So Semantium is a startup that my partner and I, Ruben Sardarian from Eastern Canada, kicked off in the last couple of months. And we have this wild ass proposition that if business concepts, metadata, and instance data found in an enterprise classify the same way, then orchestrating multiple collections should be relatively seamless and frictionless. So we're talking about using this technique end to end in the data lifecycle. And so the presentation today is going to be what we started with requirements, a bit of the solution the solution elements, including faceted classification, and then a little bit about what the solution looks like. So for those of you who know me, I've been working in this space for quite a while. This is a really exciting development for me because now it's starting to become, it's actually at the minimal viable product stage that we're looking for testers, et cetera. But yeah, I'm really excited about where this is going. So this is our requirements list. This is our wish list. We need a method that guarantees categorical separation. Sounds like kind of an obvious thing, but we were very specific about the categories had to be completely separate, mutually exclusive. So the same method has to accommodate different uses. So when we classify something, we're not so concerned about how those things show up in a model. So an entity, an attribute, metadata, it doesn't really matter. There are tendencies for these things to line up in certain ways, but for the most part, we want any entity that or any artifact that we've described to be completely reusable in any situation. We need to do the obvious semantical sort of things where we have identical items with different meanings. We have the opposite case where we have different, or we have the same shape, different shapes, the same meaning. And then we have the classic case where we have semantically equivalent terms. So those kinds of things like acronyms, abbreviations, IBM means International Business Machines. We need multiple methods for applying previously identified items. This is, again, reuse is a big theme here for us. The artifacts or the words and terms that we declare in a business glossary have to be available to show up in any application that the enterprise wants. So process diagrams, forms, documents as metadata for documents, for example, as tags, even putting geolocation content in place. Different views of the same collection and consolidations must be available without any additional modeling. So what that means is the classifications that we're using upstream to classify business catalogs and data catalogs, etc. Those same dimensions and facets flow all the way down, all the way out to business intelligence. I'm just going to reduce that a bit. So the resulting assembly has to be technology agnostic, language neutral, domain independent. Right now, we're using Neo4j as our property graph. The translation to RDF is coming. It's not really difficult, but it's on its way to make this number 7 come true. And then the final sort of thing that we had in our wish list was this can't take 6 months or a year to get up and rolling. We're talking about less than 2 months to deliver value. And typically that shows up as a business glossary. So here's our solution components. Facets are mutually exclusive and collectively. This is the Mies thing. I go back to Ranganathan, his colon classification protocols for library books. We just expanded on that. So we wound up with 19 facets in this model. A dimension is simply a facet in disguise. It's equivalent to a facet, but they're normally found in analytics and data warehouse applications. So what in the course of my work over the last 30 years, when I started doing sort of nascent data warehouse stuff on a green screen, believe it or not, it turned out that the dimensions of those backed all the way up into vocabulary management. For natural language, we use this Mies again, and we talked about this in the requirements. strings with identical shapes and different meanings, words with different shapes and equivalent meanings, and then different shapes and different meanings, or it's obviously the default case. Functional independence, again, this is every unit is called a quant. When they are identified, classified, and registered, which simply means they're recorded in the graph, they can be used anywhere. And then finally, universality. This is one that gives some modelers pause. Every quant, every artifact of information in the Semantium ecosystem has exactly the same set of property keys. There's 12 of them. And so everything is the differentiator is in the class and the types, but the property keys are exactly the same. So it's a completely language-driven model. So this is what the enums look like for quant levels, classes, and types. The property list on the right there is basically reflected in these three in the middle. So there's digital object ID, quant level, quant class, quant type. A quant is defined as an atomic unit of of communication, excuse me, not information. An atomic simply means that it's reusable as it is. It doesn't mean necessarily that it's like one word, like accounting or assessment. It could be a word like customer, or it could be a word like IBM customer, or it could be a phrase like IBM preferred customer, but it's atomic, it's reusable, it's understandable. All of its elements have been declared. The quant levels recognizable, I think, to everybody in the call. Business concepts, metadata or structural labels on, say, for example, relational database tables, and then instance data. Interestingly enough, in the last couple of months, I've been realizing that there's patterns around what can fit into which of these classes fit into these buckets, but we'll leave that for another conversation. The quant classes, they're based on the Rudyard Kipling's 6 honest serving men: who, what, when, where, why, and how. The premise is that every business, and I think Ron mentioned it and a couple of other presenters mentioned, there's core business concepts that show up everywhere. So the who, what, when, where, why, and how, and then the expansion of those 6 classes results in this list, this colored list. So here's the who classes: organization or person. The what class could be an abstract thing, a digital thing, or a physical thing. The when classes, you have cycles, points, or simply dates, points in time, spans, and status. Place, or sorry, location, you have coordinates. These can be anything from GPS coordinate to a URL. We have place. This is standard kind of, Toronto, Copenhagen, that kind of thing. Position, that this comes in particularly handy in medical terminology, where you have things like distal and proximal and all those kinds of fun words. This is the why. This is a little different than the Zachman, if some of you recognize the who, what, when, where, why from Zachman, but the why doesn't concern itself with motivation or reason or that kind of thing. Why is all about function. So roles tend to attach to people and use tend to attach to man-made objects. And then this is the how: activities, events, process, and tasks. Quant types are simply a way of expressing a way of recording how a particular quant is expressed. So for example, if I have an organization abbreviation like IBM, or sorry, an acronym like IBM, International Business Machines is equivalent to that organizational, but this is just a way of modes of expression, if you will. We also have 8 admin properties. It keeps track of things like temporality. So for example, if an existing active edge goes from the present tense to the past tense, we can simply switch those, and that's what the admin properties are there to take care of. So here's here's sort of the concentric circle about how these all work together. So the semantic core is a faceted vocabulary of abstract entities. The metadata level is a faceted vocabulary. These all use exactly the same classification techniques. These are structural entities found in data stores. Instance data is a faceted vocabulary of traditional entity sets like person, place, and physical things. And then finally, the outer layer, supported by the 3 inner circles, is where the analytics show up. So every time you see a term or a metadata value or an instance value in an analytic setting, you can get back to its definition, its semantic core, simply by navigating to in the graph. So just to sort of nail this down in sort of a practical example, I was asked about 8 years ago with Alberta Health Services, which is our provincial health authority, to put together a proof of concept to show how this might work for surgery wait time. So the objective was to integrate these different sources of data and provide statistics on the difference between, or the gap between, decision to treat, which is typically done in a surgeon's office, and then surgery, which is done in a hospital. They wanted to know how long it takes, how long people are waiting for their surgery. These are the relative dimensions / facets. They wanted to know age at the time of surgery, gender, home city, the usual suspects. They how old were these people, when gender analysis, that type of thing. Where do they come from? What type of surgery do they have, etc. So can I get a time check, Christian?
You're fine. You're 10 minutes in.
Oh, perfect. Halfway. Excellent. Okay. So here's the Semantium MVP view of what exactly we did. And so what I'm going to do in the next few slides is I'm going to show you these different levels, but I'm also going to show you the quant levels first for all of these, for these expanded. I'll expand these concepts of residence, patient, surgery, and orthopedic surgeon. And then I'm going to switch gears and show you how they're represented in terms of classification. So this is the different views. In Semantium, this is how I arrived at this particular graph. I put in, we put in double quotes, that means an exact match. So I put in patient, surgery, orthopedic surgeon, and residence. And these are all business concepts. So in a surgical event, we have a participant, a participant of a orthopedic surgeon, another participant of patient, and then we have the patient has a residence. So that's how those are separated in the model. So we have this residence concept. This is the metadata from the residence that was in that particular table. So we were given street address, province, city, etc. I'll get to the reusable cluster in a second. And then these are the instance data. So this is strictly from the level in the model, the data that we were given. This was the concept. This was the metadata we were given. And this is the instance data. The reason I've drawn this dashed line is because this is a reusable cluster. So this configuration can plug into a hospital location, an office location, anything with a physical presence. These four, at least these four, can be plugged in as a unit to acquire these particular instance data. So swappable simply means it's a, it's a variable. I can just put anything, any value I want in there, as long as it's maintains its functional class of use. So this is the patient view. Again, this data wasn't normalized. I wouldn't organize it this way, but this is how it came out. Metadata, instance data. The interesting thing about this is they also included a reference table. So this is how equivalence is managed in Semantium. We have a code M is equivalent to the word male, both status values. This one is interesting because we use this one to connect to the surgery data. So the patient has a universal lifetime identifier. They call it a ULI, and that name, so that identifier is equivalent to the person's name, Adam Keller. And then we have birth date. So this is something else that people find hard to believe, is that we actually classify and store date values. And the reason we do that is because a lot of time in data governance and cleanup is spent creating equivalent values for dates. So we put points in time as a facet. And here's the last one in this list. I didn't do the orthopedic surgeon thing because I was running out of room. I ran out of territory, real estate. So same kind of idea. We have surgery event in the middle. There's all of your information, the patient ID. This is that ULI that I talked about, the 348-8705-010. That actually connects this surgical table to the patient table. And again, the point in time, the decision date is July 11, 2011. Surgery date was April 12, 2012. So there's a wait of about 7 months there. So this is the key metric that we were looking at. Okay, so we're going to flip over now to the quant classes. We're going to put exactly the same structures up. This is the concept. Residence is a use, so it maps to this facet. These are the metadata values. They're all concepts. And then this is the classification for the quant classes for coordinates, place, so city, et cetera, et cetera. Similarly, notice we're still using the same query. We've just expanded these nodes. So we have a patient role, and then we have all of these metadata values, and then we have these instance values. The purple ones are purple people. That's interesting. And status is in green. This one's a male code, and this is the male word. And then we have, again, point in time over here. And then finally, we have the surgical concepts, the surgery event itself. The process is in blue. Events are in a different shade of blue, but that's an event. So this number represents an instance of a surgical event. We have points in time like we had before, et cetera, et cetera. So this is kind of the quant class view. Excuse me, the quant class view. You can filter this pretty much any way you want to in Semantium based on the levels, the quant classes. You can even filter on properties if you want. But the way to do this, you can, if you want to get a list of all of the organizations in your graph, you simply use the star in search and filter on organizations. So it'll give you a complete display of all the organizations, and you simply drill into those. So this is what it looks like all together. So this is the model. Like I say, I didn't put the orthopedic surgeon off to the left here, but this is the model levels. So concept, or sorry, business concept, and they have different classifications. This is the metadata in dark blue, and then the instance values in light blue. This is what it looks like when you switch filters from the level view to the class view. Again, these are the connectors. These are the concepts the business concepts, and then these are metadata in the sort of the maroon color. And then we have the classes of instance data on around the edges. So the money shot. So we put this together in 2014. We didn't have any BI tools at our disposal, so we simply mocked it up in Excel. And I can hear my old partner going boo, boo, hiss. But here it is. It gets the message across that all of the requirements for integrating these four data stores gave us surgery by month by gender. We simply put it on a timeline, with by month between, for that particular span of time. We have surgery wait times in weeks. So from that decision to treat to surgical operations, this is how this graphed out, the comparison. The median was 24, 2 years, which is kind of a long time. So they're trying to push all of this long tail that way, left. We even took a little bit of liberties with some maps and excuse me, plotted all of the patient address or the patient residences onto a map, and we've got them color coded by gender. And then finally, we've got what type of intervention. So the right hip, there was 51, the left hip, 34, et cetera, et cetera. And we thought that was kind of cool to put it on a graphic like that. I think medical analysis and EHR should be all graphic, but that's just me. So the faceted approach potentially touches all of these different areas. And the ones, going back to that one that says we need to guarantee results in less than 2 months, this is typically where we start. We do faceted business glossaries. So a glossary term and a definition, that constitutes a cluster, like a mini cluster, if you will. And then those would be reusable all the way out to data dictionaries. The semantic layer, obviously. Metadata management is another one where if you're doing metadata on documents as opposed to metadata on structured content or structured data, they're basically tags. The biggest problem with them is that, first of all, they're typically a pain in the butt to do. That's becoming more automated, but it's really difficult to connect. For example, all of this, if I selected a single patient, connecting all of this or all of the data to documents is not a trivial exercise. But with this, because you're reusing it, you're simply connecting a node in an existing business glossary or a data dictionary, or say a master data, to a value on a piece of content. So what the net result of that is, because all of these are facets are mutually exclusive, you can start to slice and dice content, files, and documents exactly the same way you slice and dice business intelligence stuff. Granular data governance, again, I think to Ron's point earlier, if we start paying attention to the business language first before we talk about data, a lot of these data quality issues start to go away because they're being governed upstream as opposed to somewhere down in the swamp. Orchestration and then frictionless analysis. So the frictionless analysis basically, again, because the facets are there, the analysis just falls into these facets and you start to put in counts and financial information, etc. So the mini takeaways, all business concepts and stuff can be classified the same way. So orchestrating multiple collections really becomes more straightforward and relatively seamless. Nothing's, 100% seamless, but that's the main takeaway that we'd like you to take away today. And thank you for your time.